Good morning, everyone. We're going to be going through an example from, similar to 7.1 and 7.2. A lot of people have messaged me, hey, Ms. Wimber, I don't know what I'm doing wrong. I don't know why this one didn't count for me. I will admit I am being somewhat picky, but to be fair, in a total of like 6 problems, you have the ability to do half of the rest of the work for the school year. So I'm not feeling too bad about that. So let's just go through one example here. Ammonium nitrate decomposes explosively to form nitrogen, oxygen, and water vapor. One thing I will mention here is ammonium nitrate is a solid. So if you haven't seen that before, um, if you didn't know that, just go ahead and write that one down. All right, go ahead. If you haven't tried this already, pause the video and see what you can do. Now remember, we need two things. I need a balanced equation that includes states, and I want a drawing that matches the balanced equation. You good? All right, let's move on. So looking here, let's go ahead and write things out. Now ammonium, when I look up on the periodic table, is NH4 plus, and nitrate is NO3 minus. 1 plus, 1 minus, this should work out just fine. So ammonium nitrate, let's zoom in a little bit. Ammonium nitrate should be NH4NO3. Be careful with your subscripts. So these are subscripts right here. They tell us in that molecule how many there are. So there's a nitrogen with 4 hydrogens and then a nitrogen with 3 oxygens. Like I just said before here, this thing is a solid. So I'm going to go ahead and put here solid. I want that behind the formula. Some people have been writing it on top. Some people have been writing it below. I want it right there, right after the formula. Now this is going to decompose to form nitrogen. This is a Hofbrinkel, so N2. Nitrogen's one of the major components of the stuff you're breathing right now. It is a gas. Oxygen, hey, there's another Hofbrinkel, that's O2. It is also a gas. Now, water is normally a liquid, but this is water vapor. This is water that has been vaporized. So guess what? It is also a gas. So this one thing is splitting into these 3 things. All right, let's go ahead and work on the balance here. This one looks like it's going to be a little tricky to balance, and let me explain why, actually, with the pictures. So you do not have to balance with the pictures. Some people like to, some people think it's fast, some people think it's slow. I'm fine either way, you do whatever you like. But I'm going to go ahead and start drawing the pictures here now, matching this stuff. So we're going to make the nitrogens these blue. So this one has 2 of those nitrogens, and here's 2 of those nitrogens stuck together. I'll make the hydrogens white, sort of traditionally the color. Oops, come on, marker. Oh, this thing just gets weird sometimes. Like, what's going on? It's like it thinks it's down, but it's not. All right, we're gonna have to. Did someone break my tip? All right. Sorry, you guys get to all watch this because I'm not going through and re-editing all these things. NH4 and then H2O, and then lastly we'll do O with this nice orange color. There's 3 O's here. There's 2 O's here, and there's 1 O here. Now, these pictures are decent, but actually there's a problem here. I would actually mark this as wrong, so let's figure out what's going on here. You see this NH4NO3? These are not separate. They need to be stuck together. I see a lot of people separating things out. That is not how this works. These are in the same formula. They need to be together. So let's see if this is balanced or not. So let's see how this is not balanced. We've got 2 nitrogens, so far so good. 3 oxygens, 1, 2, 3 oxygens, so far so good. 4 hydrogens, only 2 hydrogens. So that's going to be a problem. There's more hydrogens on this side of the equation than there are on this side of the equation. So here's what we're going to do. We're going to go ahead and I'm going to draw another water. Because look, now we've used all of our hydrogens. Great, right? Hydrogens are all used up. But now the problem is I now have more oxygens than I should have. I have a total of 4 oxygens over here, whereas here I only have a total of 3. So you know what we need? We need a whole other one of these. Now I have a computer, so I can literally just copy and paste this. You know, so I have that little advantage, right? But so now let's count things out again. So a total of 1, 2, 3, 4 nitrogens. So we're going to have to add some more nitrogens. So now we have all of our nitrogens accounted for. The hydrogens are still not right because I have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So we need a total of 8 hydrogens here. Now there's only 4, so what I'm going to do is I'm going to go ahead and just copy these guys. All right, so let's go ahead and check one more time. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 1, 2, 3, 4. We are now balanced. I have the same atoms on both sides. So now we have to go ahead and write that down. So we needed 2 of these NH4NO3s. We needed 2 of these nitrogen molecules. We only need 1 of those oxygen molecules. By the way, you don't have to write the 1. I wouldn't mark you down, but honestly, it's traditional to not write 1s for whatever reason. And we needed 4 of these hydrogens, or 4 of these waters, excuse me. All right, this is now how I want it. Now, let me point out a few things. So see how the coefficient here is 2? Well, guess what? I have 2 separate molecules. I need 2 separate molecules. That's what this 2 means. Here, I need 2 separate molecules. 1, 2. Here, there's only 1 molecule. Right there, because there's only 1 of these. Here, there should be 4 molecules. 1, 2, 3, 4. So you see how the coefficients match the number of each particle. Now, what does the particle actually look like? Well, this one particle has 2 oxygens. That's what the subscripts mean. What is in a single particle? So in this one particle, there are 2 oxygens. In these 2 particles, each of them has 2 nitrogens. Here, these 4 particles, each of them has 2 hydrogens and an oxygen, but there are 4 particles. All right. I haven't had to use any parentheses here. I haven't had to, yeah, this is laid out exactly how I want to see it. This is the order I want to see it. Some people are still giving me equal signs. Please don't give me an equal sign. I might let you get away with it once, but ladies and gentlemen, we should be using, if I can draw it, sheesh, we should be using arrows, right? You are welcome to do your work on paper and then post an image of it. In fact, that's the best work I've seen so far has been done like that. There are some people who take the time to do it properly on a computer, and if you're one of those people, feel free. But that hasn't really been what I've seen so far. All right, if there's any questions, please feel free to message me in the classroom, message me in the Discord, come talk to me. I'll be around pretty much all day. In fact, I'm technically on right now, but no one's talking to me. All right, everyone, have yourselves a great day.